Hello guys, welcome to my channel AK Tech Services. So in this video we are going to see how to create a pulley assembly in Creo Parametric. So as same as all the previous videos, this video also going to contain three different sections. The first section we are going to see how to create the part modeling, and in second section we are going to see how to make an assembly as per the mechanism, and in third part I'm going to showcase how the assembly is going to work. So without any delay, I'm just going to start the parts. So first I click on the new command here and I just rename it as pulley 1 with the underscore here, and I just click OK, and I select the matrix as mmns part solid object and just click OK here. So a part file has been created. Now I'm going to create an extrude command. So select the extrude, click on the plane and move to the sketch command. So here I make a circle. Before circle I'm going to have a center line on both horizontal and vertical planes, and I click on the circle, and the circle diameter I'm going to have it is as 100 mm. So just click OK here, and this extrude length I'm going to have it for 10 mm in symmetrical way. So the next thing, I'm going to create a hole in between of the extrude, so where the shaft will be moved. So for that I'm able to use a hole command, but here I'm going to create as an extrude command so that I can incorporate the key features also in this. So I make a circle here. From the midpoint I'm going to draw a circle with a diameter of 35, and I'm going to have a center rectangle where I'm going to select the coincidence point of the vertical center line and the circle as a center of this rectangle, and I make a rectangle here. So this width I'm going to have it as 5, and this width I'm going to have as 10, or else we can have it as 7.5 is fine. So now I'm going to delete all the unwanted lines here. So this is how a circle with the keyhole feature has been created, and just click OK here. And this extrusion going to have the flip direction, opposite direction, so that automatically remove material option will be enabled, and just click OK. Make sure it has a through hole or the dimension which is more than the thickness of the extrude. So the third feature I'm going to use in this extrude is going to have a revolve command where we are going to have a path for the V-build. So select the revolve command here, select the right plane and move to sketch view. I'm going to click on the sketch setup, and I'm going to make the orientation as the top and just click OK. So here, since we have selected the revolve feature, I'm going to have an axis line in horizontal way and center line in vertical way. So now I'm going to take a references. I'm going to select the side surfaces of the pulley as a references, as well as the top surface here. So now I'm going to create a center line once again with the distance of 2 mm. So this 2 mm will be the total width of the belt which we are going to create. So I click on the line command. I make a V shape here where the width of the outer edge is going to have as 3 mm, and or else we can have it as 2 mm, and width of the internal edge going to have as 1 mm. Now click on the symmetry, make symmetry with the center line as well as for the bottom side. So since we are making this kind of constraint, asymmetry on the top as well as symmetry on the bottom, and width of the bottom as 1 mm and width of the top is 2 mm, so no more any constraint or the angle is not required for this. So in same way I'm going to create another profile on the left hand side as well as on the right hand side. So I'm going to have from here to here as 2 point as 3.5 mm. No, it will be like 3 mm is good. So this is a total 5. I need it for 2.5. Yeah, this would be fine. So make a line once again. Draw the same V structure in the left hand side and make parallelism for this line to this line, and parallel of the right hand side line to the right hand side line. As same as the dimensions, here also we are going to have the width which is already has been equal, and the width in the higher end is going to be as 2 mm, that is also equal since we have made it as a parallel. The only constraint here pending is the symmetry option. So we are going to make it symmetry. I hope in bottom it is not required. Yeah, since we have already made given here. So this is a way we are going to have the right hand side as well. So select all the sketches in the left hand side, click on the mirror command, select the center line, and it will be replicated on the right hand side. So just click a line once again and try to close the stretch or the loop as same as in this. So here we have created a V grooves where the V belt is going to be assembled, and just click OK. Since it is a revolve command, it is getting on the all 360-degree, but this should be as a remove material. So I click on the remove material now. So you can able to see, I will show it in the right side view. A V belt pulley has been created here, which has two and three different teeth of pulleys. So this is the first pulley which we are going to use it for the assembly. I just make a different color for this. I would like to give a steel color. And second part which we are going to create is the second pulley. For that I just click on the new command, rename it as pulley 2. So for the pulley 2 also, I'm going to use the same kind size of the shaft, which is the internal diameter, but the external outline diameter I'm going to modify as a smaller pulley for this. So in same way, I'm going to click on the extrude. Oh, sorry, I just need to make a axis lines as well before going for features. I just forgot it in the pulley 1. Let it add it in the end. So select the extrude command, click on the plane, move to the sketch view. I'm going to incorporate inner circle also in the same sketch. So this is 35 mm, and there we had a diameter as 100. Here I'm going to have it as 50, or else we'll use a 60. This is much fine. So same as the keyhole also I'm going to create here. The keyhole size, this I'm going to have 2.5, and this I'm going to have 3.5, and I'm going to delete all the unwanted lines. Click on delete segment and delete all the unwanted lines. So this is how the structure of the pulley has been created. The same as the bigger pulley, the width is 10 mm in symmetrical way. And the another feature which we are going to create is the revolve for the belt groove. That is also follows as same as the same procedure which we followed in the bigger pulley. So I just select the surfaces of the pulley edges, as well as I'm going to create an axis line and center line the same way what we did in the pulley 1. This is going to have an axis line. This we are going to have a center line with a width of 2 mm. So just select line, make a V shape here, and make a symmetric. This width is going to have 1 mm, and this width is going to have 2 mm. So in the same way, I'm going to have it for the another side as 2.5 mm from the center. Oh, sorry, I just want this dimension instead of this. I'm going to have this as 2.5. So the second left hand side is also done. I'll just select this, click on the mirror command, and make it as on the right hand side. So I'm just going to close the sketch or close the loop just like this. So the sketch is done, and just click OK here, and it is getting revolved in all 360 degree. I'm going to make it as a remove material, so the material has been removed. I just need to change the model properties to inches to mmns set. I'm going to change 1 as 1 and will regenerate. So the second pulley is also done. So I hope you have understand how to create a part modeling for a pulley here. Next we are going to see how we are going to create an assembly file. To create an assembly file, I'll just click on the new command, select the assembly, and I make it as pulley assembly, and going to click OK here. The unit is going to select as mmns assemble design absolute. Click OK. So here we are going to have a assemble where the engineering connections will be in that kind of a mechanism simulations. So I'll just going to have access lines first. Apart from these three default axis lines, I'm going to have some other planes and axes where I'm going to position the pulleys. For that, I'll just go into the front view. I need the first pulley somewhere here. So I'll just select the, I'll hide all these things. I'll select the right side plane, click on the new plane, and I'm going to have a offset distance of 200 here. So the next I'm going to have another pulley which is offset in the right hand side. So the next thing in the top plane, I'm going to select this and I'm going to have an offset of 200 and the another plane in the distance of 100 So the plane which I have created here as in the top as on the front going to have an interconnection axis where the first pulley is going to get assembled. Let me show you that. So in this axis, second pulley I'm going to assemble where the plane of 100 from the top and 200 from the right going to have the axis line. So this will be the axis line of the first pulley, this will be the axis of the second pulley. Next I'm going to create some more planes as well. Based on this, I'm going to have 100 or a kind of a 200 in the opposite direction. 200. And for that, for the right hand pulley, I'm selecting this and I'm going to have in left hand side around 350 as a distance. So now I'm going to create by intersecting these two planes an axis line. So this will be the position for the another pulley, and the same way I'm going to have a pulley which is 350 or kind of a 400 as our requirement. Next we are going to create a top plane. From this I'm going to have a pulley of 400 in bottom. Just by intersecting these two planes we'll get an axis line. So I'll just show you in the 3D view. This will be the first pulley, this will be the another pulley, this will be the version of another pulley, and this will be another pulley. So like this we are going to have four different axes with four different positions in x and y dimensions. So I'm going to have an assembly of all this here and going to show how the mechanism is going to run. As same as per your application or the requirement, however the position is required, you can modify the planes by moving the offset distance, and you can position your pulley in the location. So the next thing I'm going to click on the assembly insertion. I'm going to get the first pulley. Since the first pulley needs to get assembled here, I'm going to have a pin connection here. Select the pin type, and for that I'm going to select the axis of the pulley constraint coincidence with the axis which we have created in the assembly. And for the translation, selecting the front plane, and to the front plane in assembly going to get constraints. So this is the position of first pulley. Next I'm going to have the second pulley. For the second also I'm going to use the same pulley underscore 1. For this also I'm going to use a pin connection. The first constraint is going to have access to the second axis which we have created here. And for the translation I'm going to select the front plane of the pulley to front plane of the assembly. So the next we are going to have a second pulley here and second pulley as here. So I'm selecting pulley 2. This is also going to have a pin connection where I'm going to have a axis to axis constraints. And for translation, front plane to as a front plane of assembly. The fourth one, I'm going to use the first pulley itself, so that once again it will be as a bigger one. I'm selecting the pin connection, select the axis to this axis. And for translation, I'm selecting the front plane to the front plane. So this is how I have given questions for the pulleys in different locations as different sizes. So just for better understanding, I'm going to remodify the offsets of the pulley little bit closer to each other and everything. So this I'm going to modify as 150. Just click OK. You can modify this pulley also as to the 115 x-axis, and the height I'm going to modify this as, instead of 100 I'm going to have it as 75, and for this, instead of 200 I'm going to have it as 150. The same way here, if for this distance, instead of 400 I'm going to have it as 200, and for this side plane also I'm going to have it as 300. Yeah. So the next, this plane also I'm going to have it as 250, and this height I'm going to constrain as 100. So likewise, you can able to modify the planes and of the constraints which is your requirement as per your application. Wherever the pulley is needed, you can just modify it likewise. So for the coloring, I'm going to have a different colors for the different pulleys here, so it will be have a better understanding. So for the first one pulley, I'm going to have it as a green color. For the second one, I'm going to have it as a red color. For the third one, I'm going to have it as blue. And for fourth one, I'm going to have it as yellow. So we have four different colors of four different pulleys, which is assembled in its different locations. So I hope you have understand how to make an assembly as per the pin connection and as per the location which is required for you. The third section, we are going to enter how to make a mechanism. So for that, we are going to applications workbench and click on the mechanism. So in mechanism, first we need to assign a belt for all these pulleys and how the belt is going to be rotate. So for that, I'm going to click on the belts here, and in references it's going to ask to select at least two items, but it is not a constraint for a number of quantities. You can select n number of pulleys that is you're going to have in your application. So first I'm selecting this as a first pulley. Okay, you should select the access line here. The second one, you can, I'm selecting this one. Just hold the control button. I'm selecting this as a first. Hold the control button and you can select the second one. Once you selected the second pulley, you can able to see the diameter of the belt which you need to be defined. This is a diameter of 100, so I'm converting this diameter as 100 and this also as 100. So next, you're going to add a third pulley. No issues. You can just click here, hold the control button, and you can select the third axis of the pulley. So you can able to see a belt drive has been created in all three ways. For the third pulley also, I'm going to have it as 100 mm. The next fourth one also, I'm going to use a control button, select the fourth one. You can able to see this diameter is around 60 mm, so I'm modifying this as 60. But here you can able to see, since we have selected this as a fourth pulley, the belt has got crossed one to each other. So just to modify this, either you can use two methods. First method is you can modify the position of the pulley like this, in this way. So when we keep it as a third pulley, the position is fine. Or else the second method is you can just swap the rope however it is required for it. So here I'm making here, this is also fine. I just wanted to modify only this because so that I can avoid this particular cross. So I just drag this point to the opposite side, and this one also I need to make it to the opposite side. And even now the only crosses here, this we can't able to avoid. In case if we try to make this to the opposite side, we will get a cross here. So all the positions of the dots are fine. So the only method we need to constrain is we need to make this fourth pulley as a third pulley. So just for that, select this fourth pulley and click on the one up arrow, so you can modify like this. So once again, I'm reverting the directions of this white dot so that you can have a proper bolt drive here. So this is how you are going to constrain the mechanism of a belts here, and please make sure you have entered the correct diameter value and with the number of wraps in this. So I just click OK here. So the belt has been assigned. In this belt, if you wanted to make a exact belt model, you can make it as a CAD model also. For that, you can just close this application, and here you can able to see the belt. So you can just going to create a new part. I'll just create a part with a copy empty, and in this belt I can able to get a copy geometry of this. Okay, it is not possible. I can just make it as activate, and I can able to use this same profile to create a belt or a sweep command like that. Now I'm not going to do that particular operation, so I'm just going to run only the assembly, how the mechanism is going to work. So for that, once again I'm going to click on the applications, click on the mechanisms, and going to show how the belt drive is going to rotate. For the better understanding, I'm going to move it on the front view, so you can able to see whenever I'm going to run this mechanism, the keyhole feature which I have given in the pulleys will be rotate. So for that, I'm going to click on a servo motor. I'm going to assign the motor only for the one driving pulley, rest all the three are will be as a driven pulleys. So this servo motor going to have an angular velocity of the value of 5 degrees per second, and just click OK, make it in the front view, and I'm going to make it as in a proper orientation, and I'm going to click on the mechanism analysis. Enter the start time as 0 and end time is 100 or 200, however you want, and you can just click on the run command so that you can able to see the pulleys are started to rotate just because of the belt drive which we have connected over the each pulleys. So the motor drive is going to run only the driving pulley with the 5 degrees per second. Just because of the belt drive which we have connected between all the pulleys, it makes the other pulleys also to be rotate in the same RPM. So guys, I hope you have understand this video and you have liked this video. If you really like this video, please hit on the like button and give your questions and the queries in the comment box, and also please share it with your mechanical friends who is very much interested in CAD modelings. So I hope we'll see in the next video soon. The next video will come on the couplings. So thank you for subscribing, and we'll see you in the next video. Bye bye.